let's talk about reflection models. Here we have our surface, okay, and we have our incident light and it's coming in. And it's coming in some particular direction, and this will be some theta I, which is going to be the tilt off of the surface normal. The first physical process I want to talk about is referred to as sort of body reflection. And what happens is the light comes in and it sort of scatters around at the top part of the surface, and then it comes out in lots of different directions. And therefore, it's impacted by the stuff that's in the surface, all right? And that's referred to as diffuse or body reflection, okay? And it tends to have what's referred to as a matte appearance and some sort of very, what's referred to as non-homogeneous sort of particulate matter have that kind of reflection. So this example here is this clay pot. If you think of this clay pot and you look at it, in some sense there's no shininess to it at all, right? It's purely matte. It's purely diffuse. And in particular, we'll talk later, no matter what direction you look at it, it seems to be approximately the same brightness. It turns out it's actually pretty hard to make purely matte surfaces. Like if you take matte spray paint and you spray something, even then there's sort of a certain amount of shininess to it, which we'll get to in a minute. But the general model that we're looking at of body reflection is the light comes in, is scattered about in the medium of the surface, and then goes out in a variety of directions. So that's the body or diffuse reflection model. So what else can happen to the light? Well, the other thing that can happen to the light is referred to as a specular reflection, okay? So a specular reflection, just like you think, some of the light before we saw it penetrates down, etc., but some of the light doesn't. It just bounces straight back up, okay? And that's referred to as surface reflection. And surface reflection is a specular reflection, and it's responsible for sort of the glossy highlights that you see on shiny surfaces and in metals in particular. So here's a picture of a variety of things. This one, by the way, is a fake picture that's to show you the highlights. But for example, shiny metal things, this metal pot. Here's an interesting one, right? Here's a can that clearly has stuff painted on it, right? So that's affecting the light coming in, it scatters around and bounces out. But you see also that there's this stripe here, right? Well, that stripe is the specular component of what's there. By the way, if you want to study more about specular things, the reason it works in metals, it has to do with the way the light interacts with the electrons that are in the surface. And that's part of what makes metals metals, or these free electrons. Go take a look at your material science stuff. But those sort of atomic physical properties have an impact on how light behaves when it hits the surface, all right? And that's your specular reflection. And the general overall view of the universe is that the image intensity can be thought of as a combination of the body reflection plus the surface reflection. Okay? And as a reasonable model for what's going on, we can sort of model most surfaces as having a certain component of body or matte reflection plus specular reflection.